Well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 28 is on the screen. I'll give you some time for that. However, we don't have a lot of time, so see if we can finish that like in 5-6 minutes. And I'm going to go over a couple problems from there, show you a couple of shortcuts, and we'll go from there. Copy that and go. All right, as mentioned before, today's going to go pretty fast, so I'm going to go over the warm-up really quick just for the sake of time, see how you did with what you have so far. Here goes number one. For number one, I said look at these two numbers and see if you can find a GCF for the two numbers, for the numerator and denominator. What would be a GCF? 12, yes. 12 times 2 and 12 times 5. That is correct. So, do you see a giant 1 here? Yeah, 12 divided by 12 is 1. What does that leave us with? That leaves us with 2/5. Okay, let's go to part B. When you factor the numerator is 5 times t times t times t. Notice there's multiplication all the way through. Okay? What about the denominator? Is the GCF for these two right here? Yeah. 5 and a t, 5t. And that leaves us with 2t plus 3. Yes? All right. So, do we have a giant 1? Yes, 5 over 5 and t over t. What does that leave us in the numerator? T to the second. What does that leave us with the denominator? 2t plus 3. Now, I've been giving you these for a couple of weeks already. You should be familiar with that, yeah? Yes, Mr. Q. All right. Let's go to number 2. For number 2, I need you to pay close attention to these because today I'm going to show you the shortcut. We've been doing the long version because I wanted you to practice regrouping, factor by grouping, and doing other steps. But today I'm just going to have you write the shortcut straight from the Power Ranger. So look up to the screen. Here we go. So how do we factor this? What goes on top? 1 times negative 18 is negative 18. What goes on the bottom? The 7. What two numbers multiply to give me 18 that when you combine them give us 7? Oh, negative 18. So that's negative 2 and 9. Negative 2 times 9 is negative 18. Negative 2 plus 9 is 7. So the shortcut is this. If the leading coefficient, that one, doesn't have a number aside from 1, then you can factor it, x times x. Is that correct? And then just use this number for one and this number for the other, and these are my factors. Some of you are like, I knew this, Mr. Q. I was trying to do that at the beginning. Yes, but I wanted to give you extra practice with the grouping process. But for tonight, since they're going to ask you to factor, I want you to use this shortcut so you can go a little bit faster. Okay? Any questions with a shortcut? We good? All right. Let's do one more of these just to make sure we got it. X squared plus 5x plus 6. Don't copy this. What goes on top? What goes underneath? 5. Factors of 6 that add up to 5. 2 and 3. So my factors are x plus 2 and x plus 3. We got it, yes? All right. Let's go with this one. What goes on top? Well, 6 times 2 is 12. What goes underneath? 7. What two numbers multiply to give me 12 that when you add them give us 7? 3 and 4. All right. So writing your utensils down, let me show you the shortcut for this one. Whenever you have these kind of polynomials and they ask you to factor like this, now I'm going to take the leading coefficient and write it for these to make two fractions, 6 over 3 and 6 over 4. Then I ask the question, can I simplify this more than that? Yeah, it can divide by 3 top and bottom, and this becomes 2 over 1. Is that correct? Can I simplify this one more? Yeah, I can divide 2 top and bottom, and I end up with what? 3 over 2. Well, guess what? These are my factors. The top is the x, the bottom is the constant. So this is 2x plus 1. What is this one? 3x plus 2. Copy that. So for tonight, you can use the shortcuts. Please use the shortcuts. And by the way, this shortcut or this method for the second one was discovered by a colleague of ours that used to work for LA County. His name was Jaime Escalante. This is known as the Escalante method. And those of you might know him because of the movie Stand and Deliver. Has anybody seen the movie Stand and Deliver? Yeah. He's the one that discovered or that came up with this method. Let's do another one of these just to make sure we got it. Here we go. Let's do 3x squared plus 7x plus 2. All right. What goes on top? 6. Bottom. Factors of 6 that add up to 7. 1 and 6. Okay. So then now we have this. So I write it as a fraction. As a fraction. Can I simplify this anymore? No. How about this one? Yeah, divide by 3. So that's 1 over 2. Yes? So what is my factor for this one? 3x plus 1. How about for that one? X plus 2. That is correct. So for tonight, use those methods. So like that, it can go a little bit faster when they're asking to factor. All right, let's move on. Number 4. When you solve for y, you should have ended up with y equals negative 4x plus 3. Hands, have you got that? Okay. Domain means all x values. What are my x values? Negative 1, 0, 1. We need to find our range or the y. So let's see. Negative 1 times negative 4, that's 4 plus 3, 7. 0 times negative 4 is 0 plus 3, 3. 1 times negative 4 is negative 4 plus 3, that's negative 1. And last but not least, let's factor this one. This is 3 times 5, and this is 3 times 2. Okay. What does this one need that this one has? A 5. So I multiply top and bottom times 5. What does this one need that this one has? A 2. So I multiply top and bottom by 2. So, numerator, 4, denominator, 30, plus numerator, 25, denominator, 30. So, common denominator is 30, 29 over 30. Hands, have you got that by yourself? Yeah, let's go. All right, so notice I've been giving you plenty of practice of this because we're about to get into some more of that, but with polynomials. Trying to give you the mechanics first, okay? All right, set it aside, please. Copy the agenda for tonight. Agenda, warm-up number 28. Yes? Say that again? Your what? In a little bit. Agenda, warm-up number 28, simplify rational expressions, and tonight's home plate play sheet, practice A 10.3. All right, once you copy that, the home plate from yesterday we did here in class, that was just extra practice for you. So get a Cornell note ready. You do need a Freire model. All right. Take the passage, please. So you're going to find out in Canvas there's a new module titled Rational Expressions. A new module titled Rational Expressions. That's where you're going to find the play sheet. Okay? So get a Cornell note ready. You do need a Freire model, please. Get that set up. All right, our objective for today, I can simplify rational expressions. I can simplify rational expressions. Copy that to third gear. All right, rational expressions, what are they? They are algebraic expressions whose numerator and denominator are polynomials. Rational expressions, what are they? Algebraic expressions whose numerator and denominator are polynomials. Another way of thinking of rational expressions is just saying fractions. Rational expressions are fractions. What kind of fractions? They are algebraic expressions whose numerator and denominator are polynomials. And as I mentioned, since you were introduced to polynomials, they're not going to leave. That's it. They're there all the time. You're going to be going to Donut to get your fries or whatever you buy there, your tea. Then you're going to hear, you turn to the alley, polynomials. That's it. You're going to be going to Walmart with your family, come out, polynomials. Oh, yeah. They're there to stay. You're going to be in college. You're going to be welding somewhere. Polynomials. Oh, yes. All right. So let's see if we can picture it. Algebraic expression means it's an expression and it doesn't have what kind of symbols? If it's an expression. No equal sign, no inequality symbols, right? Okay. Algebraic meaning that it has a variable, yes? But now we have numerator and denominator, which means it's a fraction. And what do we have? Polynomials. Example, copy these, please. 6 over g plus 4, 2x plus 1 over x squared minus 15x, and 2x plus 6 over x squared plus 5x plus 6. All those are examples of rational expressions. All right. Now, as you're copying that, let's look at the definition according to the examples. It says rational expressions. They are algebraic expressions. So let's see. Do they have equal signs? No. Do they have inequality symbols? No. That's why they are expressions. Algebraic because they have variables. Okay. Now we have a numerator denominator. That means they are fractions. Okay. And what else? They are what? Polynomials. All over the place. Students, rational expressions, students. We good? Yeah? Have we been seeing these on the warm-ups? Yes. Thank you, Mr. Q. You're welcome. I got you guys. I got you. All right? Non-examples. Before you copy those, tell your neighbor the obvious reason why those are not rational expressions, please. Everyone. Equal sign, right? Those are equations. All right, so copy those, please. Let's get a couple of hashtags in here. What makes a rational expression a rational expression? Hashtag what? What is it? Hashtag what? BAM. Yeah, of course. But what makes rational expressions, look at them. If somebody walked in right now and they saw these three, what would they say they are? Fractions, yes. Hashtag fractions. What else makes them a rational expression? Can you hear? Polynomials, okay. Hashtag polynomials. How about hashtag no equal signs? Yeah? All right. All right. So, throughout your mathematical career, you've had your different teachers that introduced stuff, and they gave you guys stuff to do, and so on. But some of us might have not done a good job using mathematical terminology in class. For example, I'm pretty sure you've heard the term, just plug it in. Have you guys heard that before? Okay. I don't say that because I don't really like that term. I rather use the word evaluate or substitute. Does that make sense? But of course, you guys, that was a shortcut for you guys, plug in. So some of our teachers might have introduced terminology really well, and that's why I started giving you some other stuff throughout the school year so far. And we've already been working with solution sets. Is that correct? All right. So check this out. I'm going to use solution sets to introduce the definition of fractions. or in other words, the definition of rational expressions. Okay, I already gave you the common definition, but let me use symbols. Look up, don't copy this. All right, here we go. I'm going to break it down to make sure you see and understand what you're looking at. It says, Q stands for what? Yeah, quintanilla, right? But I let them borrow it for today, and it's quotient, which is the what? The solution or the answer to a division. Or in other words, fractions. So quotient is rationals, or fractions, is the set of all fractions. Do you see a fraction here? Yes, m over n. Let me read that again. A quotient is the set of all fractions, m over n, where m and n are integers. And what are integers? 0, 1, 2, 3, and on, and all their opposites. Okay. However, here's a disclaimer. N cannot equal to 0. Or in other words, the denominator cannot equal to 0. And I don't know if you remember your teacher saying, okay guys, we can't have the denominator 0 because the slope would be undefined. Remember something like that, some of us? Yeah? Okay, good. So, today, when we look for values that make the denominator 0, those are what we call excluded values. Why are they excluded? Because we cannot use them. That's why they are excluded. Why can't we use them? Because we cannot have the denominator equal to 0, according to the definition. Am I pretty clear on that? So what cannot be on the denominator? Tell your neighbor, please. What cannot be in the denominator? Everyone. 0. We cannot have 0 in the denominator, okay? So with that said, today I'm going to give you 3 steps to copy. That's what you're going to follow for tonight's home plate. And you need these steps just in case you get stuck with the home plate. Here we go. Steps. Number 1. Identify the excluded values. How do we do that? In parentheses, you write the denominator equal to 0 and solve. Yeah, write this down. Step 2. Then you factor completely the numerator and denominator by identifying GCF if possible. And number 3, simplify. How do you do that? By identifying giant ones. Copy that, please. All right, so I'm going to leave these 3 steps on the top right of my screen so I can get started with problem number 1. Now, problem number 1, they're going to ask me to do 2 different things, but I'm going to do all the steps together, and I'm going to show you one thing from the other, so like that you can see whenever they're asking you to do something on the home plate, you know exactly what they're asking you to do. All right? Here we go. Example number 1. Don't copy this yet. Look up to the screen. It says, identify the excluded value. Period. That means they want us to do something there first. So watch. This is one thing that they're asking you to do. For some problems, they're going to give you that and just ask you to do that. Okay. And what do I do for that, Mr. Hugh? That's step 1. But then look at the next thing. It says, then simplify to lowest terms. That's another thing that they are going to ask you to do. Is that going to be the case for all of them? No. On some of them, only the first part. On some of them, only the second part. However, how do you do that for the second part? Well, you follow the steps 2 and 3. That's why I put red and green. 2 and 3 are to simplify. Okay? So I'm going to start first with the first part, and then I'm going to go ahead and do the second part. We'll copy that, and then we'll do the next one together. So for right now, copy this so far, up to right there. All right, here we go. Writing utensils down, look up to the screen. I'm going to do, let's say for this problem, they only asked me to do identify excluded values. So I'm going to do it in a separate part so that like that you can see that it's totally different from this. So I'm going to write over here EV. What does EV stand for? Excluded value. Okay. So what does this say here for identifying excluded values? It says, write the denominator equal to 0 and solve. So what's my denominator here? 2x plus 6. So I write 2x plus 6 equal to 0. I'm going to solve. Minus 6, 2x equals negative 6, divide by 2. x equals -3. So my excluded value is -3. Now, before you copy, let's understand what that is. Here goes. Mr. Q, why is it called excluded? Well, because if I take this number in here and substitute it for x, what is -3 times 2? -6. What is -6 plus 6? 0. Can we have 0 in the denominator? No, that's why this is excluded. We can't use it. We need to identify it so like that we don't use it. So what does that mean? That we can use any other value. Tell your neighbor any value that you want to use to substitute in there. Tell your neighbor a value, please. Yeah, 23 Michael Jordan. So 23 times 2, that's 46, plus 6, that's 52. Does that give us 0 in the denominator? No, I can use that. Which is the only value that we're not going to use for the denominator? Everyone, -3, because that's our what? Excluded value. Copy that, please. All right, so for in the home play, if they ask you for this problem, they give you this algebraic expression like this, rational expression, they say identify the excluded value. What do? Take the denominator, equal it to 0, solve, and that's how you identify the excluded value, and you're done. But what if they don't ask you to do that? What if they just ask you to what? To simplify. Well, let me show you the simplification. We already did this on the warm-ups. Here we go. What is first thing we do for simplification? Factor completely the numerator and denominator. So watch. I'm going to start with the denominator. To factor this, my noodle says two things, standard form and GCF, right away, yes? Is it in standard form? Yes. What's GCF? 2. That leaves us with x plus 3. All right, it's factored completely. Let me go to the numerator. Can I factor this anymore? No. 2 times x. So question, do I have multiplication here between these two? Yes. How about between these two? Yes. I go to step 3, identify giant ones. Do you see a giant 1? Yes. What is 2 over 2? 1. What does that leave us up here? X. How about the denominator? X plus 3, and we are done. Copy that, please. And if you notice, we've been doing this on the warm-ups, yes? All right. So once again, on the home play, they might ask you to do one thing or the other. They might ask you to do both things on one. I can't recall right now from my noodle, but I know that they're going to ask you to do one or the other, okay? So, example 1Q. Do this one by yourself. We got 6x over 3x plus 9. I want you to first find me the excluded value. Then I want you to simplify to lowest terms. All right? I'll leave that example up there as an example. Go. All right, let's see. Excluded value. What did you write? The denominator, 3x plus 9 equal to 0. Then you solve. Minus 9 minus 9, 3x equals -9, divide by 3, divide by 3, x equals -3. My excluded value to stay away from is what? -3. Hands, have you got that? Okay. Next. What if they ask us to simplify? We need to factor completely first. Let's start with the denominator. Is it in standard form? Yes? GCF. 3. That leaves us with x plus 3. Okay. Next. The numerator. Can we factor this out? And we can say, well, this is 6. Can we write it now with the GCF of 3, the 6? How can we rewrite 6 using the GCF of 3? 3 times 2, is that correct? And then I'm going to write times x. So, what's my giant 1? My giant 1 is 3 over 3, and that leaves us with 2x, and the denominator, x plus 3. Hands, have you got that by yourself? Okay, we got this, right? From 1 to 5, how far are you with these so far? Okay, 4, 4, 4, 4, 4, 5, okay. Let's crank it up a little bit. Copy this one. Example 1 super cube. X squared over x squared minus 5x. We're going to do this one together, okay? We got example 1 super q, x squared over x squared minus 5x. Campos? Okay. Where to? Okay. All right. Here we go. Let's start with the excluded value, guys. Excluded value. What do I write, Diego Rosas? X squared minus 5x equal to 0. All right. Now we need to solve. But here we have a dilemma now, because now it's a quadratic. Wait. Can I do square roots? This, yes. This, no. So, in our noodle, what are the two things that we check for? Standard form or GCF? Is there a GCF? Yes, x. That leaves us with x minus 5 and all that equal to 0. What do I do next? We have this times this equal to 0. So what do I write? X equal to 0 and x minus 5 equal to 0. So this one's already solved. This one plus 5 plus 5, x equals 5. So now we have two excluded values. What are they? 0 and 5. All right? We're done with excluded value. Let's simplify to lowest terms. So let's start with the denominator. Is it in standard form? Yes. Is there a GCF? Yes. That leaves us with x minus 5. How can we factor the numerator? X times x. Question, is there multiplication here and here? Yes. So that means our giant one is x, and we're left with x over x minus 5. Woo, let's go. All right. Let's see how you do with this one by yourself. Example 1 mega q. Example 1 mega q. Saw that, Fredo? He was going to sneak one by me like when I was turning over here. My goodness. We got 2x over x squared plus 7x. Find me the excluded values, and then from there simplify to lowest terms. Go. All right. Let's see, help me out with the excluded value. Brisela, go. Tell me what you write. X squared plus 7x equals 0. Next, what did you do? X times x plus 7 equal to 0, and then?
X equals 0, and x plus 7 equals 0.
Yeah, x equals 0, x plus 7 equals 0, and then minus 7, minus 7. So x equals negative 7. So my excluded values are 0 and negative 7. Hands, have you got that? Yeah, we got this, yes? All right. Next, let's factor completely. Tell me what to do, Lorena. Denominator. And? Yeah, so she found the GCF x times 7. So, numerator. Can we factor this anymore? No, just 2 times x. And there's multiplications here. Do you see the giant one, guys? Yes, x over x. That leaves us with 2 over x plus 7. Hands, have you got that? All right, from 1 to 5, how comfortable are you with it? Yeah, 5, 5, 5. Okay, crank it up a little bit, yeah? Yeah, not that one. This one. Example 1 super duper cube. 6x squared minus 6x over 3x minus 3. See if we can go a little bit more expeditiously. All right, help me out, Christina. Excluded value, what do I do? 3x minus 3 equals 0, and then? Add 3, 3x equals 3, divide by 3, x equals 1. Our excluded value is 1. So far so good? Yes? All right. All right, so we're done with excluded value. But what if they ask us to simplify? Pass on one, Christina? All right, denominator. Anaya, what would you do? Three, yes. Then we're left with x minus 1. Yeah, the GCF is 3. Okay. Pass on one. All right, Alexandra. Numerator, what would you do? Which would be x. What else? Yes, 6x. That's our GCF. And that leaves us with x minus 1. Okay. Pretty good. Okay. Now, question. Can we write the 6 using the GCF of 3? Can we rewrite it? Yeah. What do I write? 2 times 3. Yeah. So no longer 6. We have 2 times 3. Now, why do we do that? So like that, it's easier to identify the giant 1. So first giant 1 is obvious, 3 over 3. Yes? All right. So let me show you 3 over 3. There it is. Okay. Do you see the other giant 1? Say never the other giant 1. How about x minus 1 over x minus 1? Yeah, watch. And I'm going to do a giant 1 so you guys can see it. Is that a pretty giant 1? Yeah? Yeah? Huge 1? Yeah? All right. So do we have anything left on the denominator? No. How about the numerator? We've got the 2 and the x, so this is 2x. Ooh, let's go. Or should I say, bam, let's go. Did I show you guys my shirt? Yeah? Let's go. What's that? You did? No, you hit the rim. You kind of pulled on that elbow. Anyways, let's crank it up, yeah? Copy this one. Too easy. Copy this one. Example 1, Star Wars Q. 1 Star Wars Q. You're like, what? X squared minus 4 over x squared plus 3x plus 2. All right. Who went last? Alexandra, pass someone? All right. Excluded value. Alyssa, help us out. Go. No, before, what do I write? X squared plus 3x plus 2 equal to 0. Okay, so we need to solve that. Now, your noodle should be fresh about solving these kind, yes? What do we do next? Pass someone? Christina? Factor. What number goes on top? 2. What number goes underneath? 3. What factors of 2 add up to 3? 1 and 2. Now, do we need to do the grouping and all that? No, tell your neighbor the 2 factors now that we have those 2 numbers, please. What are my factors? X plus 1 and x plus 2. That is correct. We're using the shortcut, yes? Am I done solving? No, tell your neighbor what to do from there. Set each one equal to 0, x plus 1 equal to 0, x plus 2 equal to 0, and then we solve. Minus 1 minus 1, x equals negative 1, minus 2 minus 2, x equals Negative 2. Now we have two excluded values again. Negative 1 and negative 2. All right. So we're done with excluded value. But what if they asked us to simplify? All right. Who went last? Christina, pass it one. Who? Freda? Oh, Frida. Go. What do I do in the denominator? X squared plus 3x plus 2, we need to do what? Factor completely, right? Yeah, x plus 2 and x plus 1. Yeah, so she factored. Yes? But of course you're going to check for your standard form and GCF. Yes? All right. Pass someone. Diego Romo. Look at the numerator. What are the factors for that one, please? X plus 2, x minus 2. Tell your neighbor why that is, please. Everyone, because it's difference of squares. All right. So we see a giant 1. Yeah. What is it? X plus 2. What does that leave us with? X minus 2 over x plus 1. Let's go. What? You're too slow on the pull-up, Fredo. Come on now. All right, so from 1 to 5, how comfortable are you with these right here? Yeah, so notice that now we're putting together everything that we saw from polynomials to the solving of quadratic equations. It all comes together here, okay? So once again, tonight's home play is from number 1 through 11, I believe. I think we have time for one more, no? No? Okay, I'll stop right I'll stop right there.